Hi everyone and welcome to my YouTube channel. So we're still continuing our IMO past problems playlist, and in this video we'll be discussing our third IMO, the third IMO that is 1961, which was held in Hungary. So the first two IMOs were held in Romania and the third one was held in Hungary. Of course, in this video we'll start with the first problem, that is problem 1. So actually today we're going to have like pure algebraic problem, because our problem is about solving a system of equations. Okay, so what are we waiting for? Let's get started. So the problem statements goes as follows. So we need to solve the system of equations, and we have three equations with three variables. X plus y plus z equals a, so the sum of the variables is a, and x squared plus y squared plus z squared equals b squared, so the sum of the variable squared is b squared, and we've got like this nice equation that is xy equals z squared. And then actually, of course, like we know that a and b are constants, and then after solving like x, y, and z, we need to give the conditions on a and b so that x, y, and z are distinct positive numbers. So like here we need to do two things. First of all, we need to solve these three equations, like find the values of x, y, and z. And then we need to find the conditions on a and b so that the the solutions x, y, z must be distinct positive numbers. Alright, so let's actually start by taking a look at our equations. Okay, so here our first equation is basically like the sum like x plus y plus z. So that's really nice and simple. Here actually it is also nice because the sum of squared of x, y, and z. And here this is really nice, xy equals z squared. Okay, so first of all, because we have three equations, we need to find a way to combine them, right? Okay, so how can we do that? Like here it's linear, right? Here it's second degree, because we've got squared. So what's the easiest way, the simplest way to link this equation with this equation? Well, what do you think? It's really simple. Well, to actually turn this thing into this thing, we just need to square the first equation, right? So if we square this one, we'll get sum of x squared plus 2 times sum of xy. Okay, so actually let's start by doing that. So first of all, what we will do is simple. We'll just take the first equation and square it. All right. So if we square the first equation, we'll get something like x squared plus y squared plus z squared plus 2 times xy plus yz plus zx, and that is equal to a squared. Okay, so now actually what is this? Well, this is b squared. Great. So this is basically b squared. Alright, so here we have b squared, a squared. So now we know the value of xy plus yz plus zx. However, actually, I want you to take a look here. Here we can actually do a bit better than that. Well, how can we do that? Well, don't forget our third equation. We know that xy equals z squared, right? Here's the perfect place to use this equation. Because xy equals z squared, take a look, this xy is z squared. So actually, this is z squared. And guess what? Now here we have a z, here we have a z, and here we have a z. That means we can take this z as a common factor. And guess what? Now actually if we take this z as a common factor, we'll get here z plus y plus x. Alright, so actually now we have the sum of x plus y plus z, which is again a. So actually now we just have a linear, a very simple linear equation that has just one variable, that is z. So we can immediately now find the value of z. Alright, perfect. So let's now actually write our equation. So basically now we know that b squared, alright, let's write it here. So b squared plus 2 times z times a equals a squared. Alright, so what does that mean? That simply means that 2az equals a squared minus b squared. Alright, so what is the value of c here? Well, actually here you need to discuss two cases. It's really clear. Well, if a is not 0, then simply z is just a squared minus b squared divided by 2 times a. However, we need to discuss the case when a is 0. Alright, so now we need to discuss the first case, that is a equals 0. Alright, so let's say case 1, a equals 0. Alright, so what happens if a equals 0? Well, take a look here. If a equals 0, then a squared minus b squared equals 0. Of course, like a, it's also 0. That simply means that b equals 0. Perfect. So now we know that not just a equals 0, but b equals 0. Now actually take a look here. Like we know that x squared plus y squared plus z squared equals b squared. That is 0. So actually, that means like the sum of 3 squared is 0. So that means that x equals y equals z equals 0. Of course, like actually here, like it's not clear whether we're solving the system of equations on the set of real numbers or complex numbers. However, like I believe it's real numbers because like usually if it is on complex numbers, like they should like tell us that solve it in C, for example. So we will just assume that we're going to solve it in R, and that means that x equals y equals z equals 0. And of course, like here everything is true because 0 equals 0, 0 equals 0, and 0 equals 0. Alright, so like in the case a equals 0, b equals 0, and our like system of like now the solution is simple. It is just x, y, z, the triple is just 0, 0, 0. Of course, like in this case actually, we cannot have distinct positive numbers, clearly, because they are all equal and they are all zeros. Okay, so now we just need to discuss the second case. Alright, so let's erase that. Alright, so actually let's just now assume that a is not 0. Alright, so now we know what is c, which is pretty good. We know that c is equal to a squared minus b squared divided by 2a. Perfect. We're done with one unknown variable. Okay, so now let's take a look at the other variables. Well, now actually what like our equation, what about like x and y? Here we know that xy equals z squared. So that's really nice because we know that xy equals a minus b, a squared minus b squared divided by 2a, and that's all squared. Alright, what about this one? Well, here we know that x plus y equals a minus z. What is a minus z? Like it's a minus this thing, so it's actually like 2a squared minus this the numerator here. So it's basically actually a squared plus b squared divided by 2a. Alright, so that's actually pretty good. So actually let's like write them here. Now we know that xy equals a squared minus b squared divided by 2a squared. And we also know that x plus y equals, we mentioned that it's a squared plus b squared divided by 2a, okay, just like that. Alright, of course now let's forget about like the middle one because like these two are enough actually. Okay, so how to solve these two? Like we've got two equations with two unknown variables. Well, like actually this is a rule of thumb. Whenever like you have two numbers, like two variables, x and y, so like you know what is the sum and you know what is the multiplication. Like what does that remind you? Like if you're like familiar with equations, with algebra, you should be familiar with this thing. Like when x, you know x plus y and xy. Well, that is Vieta relation, right? So like if you remember, if we have simple quadratic equations, we know that if we have two roots like x1 and x2, then x1 plus x2 is equal to minus b over a, and x1 times x2 is c over a. So basically, like if you have two roots and you know what is the sum and you know what is the multiplication, then you can actually now create a quadratic equation and where x and y are the two solutions of this equation. Alright, so actually this is really simple. Well, let's like here assume that the a here like of our equation, like the coefficient of x squared is 1. So our equation is simply the following. Okay, so let's say our equation is t, like let's write it in terms of t because we don't want to mess with x. So it's t squared plus, alright, so what is b? Well, we know that the sum is minus b, so that means like the sum here is simply, sorry, not a plus but a minus. So it is just minus a squared plus b squared over 2a t. And then what is c? So xy is just c, so that means it's just like that. Alright, so now actually we have our equation, this one, t squared minus a squared plus b squared divided by 2a times t plus a squared minus b squared over 2a squared equals 0. So what does that mean? That means that x and y are simply the two solutions of this quadratic equation. And guess what? Like we know how to solve quadratic equations, right? We just like need to find the delta of this equation and apply just like the solution for a quadratic equation. So actually we have found x and y. Like you can of course like write them, write the possibilities for x and y. Like actually we have here two cases, but basically like we can for sure here find x and y. And of course we have already found z. All right, perfect. So now we've done like the first part of the question. We've found x and y and z. We've solved the system of the three equations. Now we need to move to the second part, where we need to give the conditions on a and b so that x and y and z, so like these solutions are distinct, so like x is not equal to y and not equal to z, and they are positive numbers. Alright, so now actually let's assume that they indeed are distinct positive numbers, and let's find the conditions on a and b. Okay, so actually this is really not that difficult. Let's just take a look at our equations. Let's assume that they are distinct positive numbers. Well, take a look here. X plus y plus z. These are all positive, right? That means that a is positive. Okay? Oh, actually, let's first of all erase. All right, let's just keep these because maybe we'll need them. Okay, so now we know that first of all, a is positive because it's the sum of three positive numbers. So actually, let's write everything we get so that we don't forget anything. So first of all, we know that a must be positive. Great. So that's the first thing. Well, here like of course like we cannot know anything because b might be negative, and here actually we don't know anything. Okay. What next? We know that a is positive. Is that enough? Of course no. Second, we know that we found the value of z, right? This is z, a squared minus b squared divided by 2 times a. We know that z is positive, all right, and a is positive. That simply means that a squared minus b squared is positive. Perfect, so that simply means that a squared is greater than b squared. Perfect, so that's actually our second thing. In fact, now we don't even need this because, or actually you still need it. No, forget about that. So a squared is greater than b squared and a is positive. Okay, what next? Well, now we have our this equation. Like we know that what is the value of x and y, right? Well, actually before we even have the conditions, they are distinct positive numbers, they should exist, right? Because if they are distinct positive numbers, then of course they exist. So that means that we need to find what is the delta here and solve or know what are the conditions for the delta to be strictly positive, right? Alright, so now actually we need to find the delta of this equation, and that's not that difficult. Well, let's just apply the delta rule. So it's just a squared plus b squared divided by 2a squared minus 4 times this. In fact, let's get a 2 inside here. So it's simply 2a squared minus b squared divided by 2a squared And what is that? Well, now we can just apply like the rule of the difference of two perfect squares. So that's simply, actually, like, let's take a look here. A squared plus b squared minus 2a squared minus b squared. In fact, this is just 3b squared minus a squared times, of course, like it's like symmetric here. So 3a squared minus b squared divided by 4a squared. Alright, so that's actually our delta here. Alright, so delta must be positive, right? Well, first of all, a is positive, great. Like here, the denominator is positive, so we must have the numerator is positive, but it's the multiplication of two expressions. So they both are positive or they both are negative. However, take a look. Can they both be negative? What do you think? Well, if they are both are negative, then sum them up. They should be negative, right? Well, what is their sum? Take a look. It's 2 times a squared plus b squared. Well, this is positive, right? So they cannot actually, like, both of them be negative. So that leaves us with only one case, that they are both positive. What does that mean, like they are both positive? Well, we must have 3b squared is greater than a squared, and 3a squared is greater than b squared. Well, actually, take a look at this one. Like, of course it's positive, right? Because we know that a squared is greater than b squared, so 3a squared is greater than 3b squared, minus b squared, that means it's greater than 2b squared. So in fact, like, this is even better than this one. So like, we can just ignore this. However, this is important because now we know that 3b squared minus a squared is positive, meaning that a squared is less than 3b squared. Alright, so now actually we just like need to add the following condition. So let's just erase this. Put it here. Like, we know that a is positive. We know that a squared is between b squared and 3b squared. Alright. Well, actually here, like, because we know a is positive, we can turn this like into like just like we know that a is greater than the absolute value of b and is less than the square root of 3 times just the absolute value of b. Okay? Okay. But is that enough? Like, are we done actually? Well, let's take a look here. Now, if like we have these two conditions, we know that z is positive for sure, right? The numerator is positive, the denominator is positive. X and y, are they positive? Well, they exist now. However, are they positive? Well, it's not necessarily, right? However, let's take a look here. We know that xy is positive because it's z squared, right? So either they're both positive or they're both negative. So if they are not like both positive, then they are both negative, right? However, take a look here. Like, x plus y is a squared plus b squared divided by 2a. This is positive, so again, like, they cannot be negative, both of them. That means that they indeed are positive. So perfect. Now actually, with these just two conditions, we know that x, y, and z are positive. However, now we need to discuss, are they really distinct? Well, first of all, luckily, here we know that delta is greater than 0, right? Because like here, we don't have equal in our inequality. So that means that delta is greater than 0, so the two solutions are distinct. So x cannot be equal to y. However, maybe z equals x or z equals y. So can this be true? Well, let's take a look here. Again, we'll take a look at our really simple, adorable equation. Take a look here. If x equals z, then you can divide by x, for example, like here, and of course, like, you will get just y equals x. So that means x equals y equals z. And again, like, this is a contradiction here, right? Because here we mentioned that x cannot be equal to y. So in fact, they are indeed distinct positive numbers. And actually we are done, because now we know that, like, first of all, we solved the equation, and we gave the conditions on a and b so that they are distinct positive numbers. So these are like the two conditions: a is greater than 0 and a squared is between b squared and 3b squared. And as I told you, like you can write it, in fact, you can ignore in fact this thing and just say a is greater than the absolute value of b and is less than the square root of 3 times the absolute value of b. Because now, in fact, because a is greater than the absolute value of b, that naturally means that a is positive. Alright, so actually that's our solution for this problem. So as a summary, like in this problem, what we did was really simple. Like in fact, we can generalize like the algorithm when we have any system of equations. First of all, we took a look at our equations. We try to link them together. So we know here like the sum and the sum of square. So how to combine them together? Simply square the first one. And immediately when we squared and used this adorable equation, we immediately got the value of c. We discussed two cases. They were simple. So the first one was simple. So the other one immediately gave us the value of c. Okay, so now we know what is z. That means we know what is xy and what is x plus y. And immediately that should always remind you of the Vieta, meaning that you should immediately just like create or form the quadratic equation that x and y are both the solutions of. And like of course when we did that, we solved the system of the equation. Then we discussed like when a and b are like what the conditions on a and b, such that like we have three solutions that are distinct positive numbers. And we like started a bit by a bit, like each time we find some simple condition. So first of all, a is greater than 0, then a squared is greater than b squared. Then from here, because the delta is positive, we must have 3b squared is greater than a squared. And like we've proven that these are enough in order for x, y, and z to be distinct positive numbers. Alright, so that's like for problem 1 in the third IMO. So in the next video, we'll probably discuss the problem 4, of course, in the same IMO. So I hope guys you enjoyed the video. So please like, share, and subscribe to the channel, and see you guys in the next video.